This conference will now be recorded.
Yesterday we tried to send this data through Kafka, right? So this is our data frame, some batch data. I mean to say this is some batch data we tried to send through Kafka, correct?
Yes.
The mistake what I did, since I have copied the data from the sample producer, I have used same. I have used the same like your producer config dot bootstrap servers, correct? But now when we are sending the data through um, Scala, in Scala, you have a different kind of property, that is Kafka dot bootstrap dot servers. This is the one. Okay, and your bootstrap server ID and topic is your topic. And these are all checkpointing and all I'll explain. So checkpointing directory and all come in the streaming process. Rest all same. But one thing, right? So whenever you are sending the data, whenever you're sending the data through um, Kafka, right? It has to be key value paired, correct? That's what we learn, no? So in Kafka also, when we're sending the data through key value pair, we will send the data. But
Yes.
here we are sending the data frame. So data frame is nothing but what? Data frame is nothing but a data frame is nothing but a table, correct?
Yes.
Data frame is nothing but a table. So when we cannot send a table directly, right? So it has to be key value pair. For that, still that was the reason we are getting the issue. Value has to be there. Value has to be there. Value is missing something, right? So that's the reason behind it. You cannot send the data frame directly through a Kafka. It has to be either a key value pair or uh, it has to be like a simple text. So since I'm sending a data frame, so what I have done, I have converted to JSON to JSON. Okay. So since I have converted to JSON, then I'm able to send the data. Let me show you that. Okay. This is my producer. This is my producer, and this is your consumer. I mean, not any consumer. I'm not a consumer. We have already that I have used that consumer. Okay. Let me run this. So if you want, you can have a look of the whole code once again. So let me do one thing. One second. Our Spark session. This is common code, right? So to create your Spark session, this is your aware, right? I think
Yes, Ravi.
we, I mean, we are very much familiar with this, right? So next, this is our employee data, whatever the data we cooked up, and this is columns, and we're creating a data frame here. Till here, you're very much clear, no? Since it is this is common, our whatever we did, the same
Yes.
one, right? It is not something new, right? Next, here, this is what we need to small change, which you need to understand. Rest all what you already know. Rest all you already know. Once you have fine understanding, please let me know. So I can just go ahead and execute it. Do you understand this part more?
Yes, Ravi. We can execute.
It is writing. Okay, it's writing. Right click, run as this producer, go to your consumer. Actually, consumer could have started first. No problem. So I mean, it can read. The consumer is a simple consumer. So there is nothing special. Simple consumer. Look at here. This is published. It is started reading. Let me clear once again. Run this once again. Okay, the messages are coming. Since I have converted into JSON, the first field is employee name, second field is month, third field is income. Okay, any doubt, ma?
Good, Ravi.
So this is how we will publish the message. Okay. Now, before we get into further, okay. So let me explain something here. So you may ask, is there any alternative without converting Spark streaming? Is there any alternative? I mean, JSON. Is there any alternative you can send a data? You can send data. That alternative is, yes, we do. We have an alternate. That is, I can say, if you have only two columns, if you have only two columns in your data frame, you can say one column is a key, next column is a value. You can send it. Or if you have multiple columns, either you have to convert as a JSON, or you have to convert it as a uh, either you have to convert it as a arrow. There is another way of doing it is arrow. Okay. So with this, we will I can say we'll execute these programs.
Okay.
Okay. Either you have to convert it JSON or you have to convert it as an arrow file. Now let's start discuss about something called Spark streaming. Spark streaming. What is Spark streaming? What is Spark streaming? Spark streaming is like how you have a different libraries like Spark Core, Spark SQL. Spark streaming is also one of the library where it will start collect the data from the any streaming application like KAFKA, RabbitMQ, or any other. Okay, to collect the data, it has a receiver. Okay, it has a receivers internally. What these receivers do, there are two type of receivers: direct stream receiver. Other one is a direct stream. Other one is a receiver based stream. There are two type of streams are there. What these streams will do, they will start collect the data. See, but by saying this is not actually streaming. This is not actually streaming. You are just sending a message and you are collecting as a consumer. Yes, you can say it is a looks like you are collecting the data whenever you are getting from Kafka. It is just a consumer. It is not a streaming application. It is not actually streaming application. So to see the real streaming application, to see a real streaming application, that's a different. We have to create our Spark streaming context, and we have to what I can say. Uh, then we have to connect to Kafka, respective topic and all. Here, what are you doing? This is a small, simple consumer. It's not Spark streaming consumer. So I can say it's a plain Java simple consumer. It is not streaming. It's not Spark streaming consumer. Spark streaming consumer is actually different. So how it looks, I will show you on real-time code. So that will let me help you. Okay, let me show that. It's a real-time code. One of our student is got job, and when he placed, so he got that job, and that's the first task he started working on it. Let's show you. Is my screen is visible?
Yes, Ravi.
Okay. So please concentrate a little bit more here, because you should experience like you have written this code. I'll explain line by line code. I'll explain this line by line code. Feel like you have written this code. Whenever anyone asks for an interview, you should say these details. Okay. Okay. First thing, if you want to connect to Kafka, what are the prerequisites? What are the prerequisites? Very simple. You need the Kafka details, right?
Yes.
You need a Kafka details, right? Yes or no?
Yes. Like broker
Okay.
and the consumer.
Yes. Brokers, topic, right? You need this information, correct? Okay. So look at here. This is the real-time code. One of the customer in Canada. 5 TV. I think you might have forgot this thing. Okay. The company is country name. I don't have this. I think I might have removed the client name. 5 TV itself is the company name, I think. Okay. So the main method. These are all the arguments which you get to this job. While executing this job, we will give some arguments, right? I think yesterday I have shown in while explaining Scala code, runtime, runtime application. And also I have shown this one, right? When you Spark submit, when you try to do the Spark submit, we will give some parameters. Do you remember that? We have discussed this
Yes.
also. While you're doing a Spark submit, class, master, deployment mode, configurations, any other parameters, application parameters. Application parameters means what? Application parameter means what? The arguments passed to the main method. The arguments passed to the main method. You aware this, right? Suppose I want to find uh, pi, pi value, or suppose I want to find anything. Any values or any command line arguments you send to your application. Those we will call as a command line arguments or application arguments. You remember these things, no? I think you are aware of this also. If you don't, please let me know. I'll explain you. Yes, no, Prabhuna, and others.
Yes, Ravi. I know.
You're right. So when
Yeah.
you submit this, these parameters are what actually here it is doing. Those parameters is just printing in the console. Okay, these are the parameters I have received. argument of 0, argument of 1, argument of 2, 3, 4, 5, 6, 7, and so on. These are the parameters it receives. In this, there are three parameters: some helper 1, helper 2, helper 3, maybe specific to his application. These are not common. But Impala host, because he is connecting to Impala, so this is Impala host. Broker, topic, consumer group, SSL, structural key location, password, in interval, window interval. These are all common. These are all common. When you are connecting to Kafka topic, if it is within the cluster, in your cluster only you have a Kafka, let's assume that. In your cluster only you have Kafka. I mean, in your premises, you have a control on the cluster. Then you really no need to send all these details. By default, everything will be taken local, or by default, everything will be taken in the that you will be having access to that. But when you're connecting to other cluster, where you're not authorized to access directly, you have to send your SSL, secure socket link, trusted key location, store location, trusted password. Okay, you need to send these parameters. Apart from broker, you know what is a broker, topic, you know, consumer group, you know. These are to connect to the external Kafka topic, an external Kafka topic, and this is the batch interval. So Spark streaming is, we'll talk about it in detail. Spark is not a real-time streaming. Real-time streaming means as soon as the feed comes or as soon as the message comes, it has to pick and process. That is the real time. That real time we will call it as a Strom. There are some other applications. What they will do, they will directly as soon as the data comes, they will take and they will process it. But Spark will not do like that. Spark is always a batch process. But but internally, the Spark streaming, what it does, it creates a micro batches. It creates the micro batches. For example, for example, to make you understand, let me show you a simple diagram. Whenever a feed will be created small batches, batch 1, batch 2, batch 3, like this. It will create a small batches. The small batches we will call micro batches. This is windowing. This is different thing. I'm trying to show you some diagram. Whatever the once the feed comes, it create the batches, batch 1, batch 2, batch 3. It will create a batches. It will process batches only. Okay, but here batch size is very small. Batch size is very small. That small batches we'll call micro batches. Micro batches. So since it is processed batches, you will not actually feel that no, it is not real time. It is actually just a batch process. It is a kind of a near real time. We will call Spark streaming. Always we'll call near real time. It's not actually real time. It is not actually real time. It is near real time. Near real time. Is this clear, ma?
Yes,
Are
Ravi.
you following? So these batches interval it is. And actually this is window interval. This is a window interval. Window interval is there is some kind of windowing operations. One batch to another batch. What is the interval? That is this batch. I'll explain this one process. What it will happen. All these arguments, he's reading all the arguments and assigning to the first argument is the execution user, that is a helper one. User execution user key, config file, Impala host, broker, topic, consumer, SSL, and other stuff. All these things he is assigning. I mean, this can be possible in Scala. While you suppose if you have uh, var args array of name, comma age, comma sal. What I can do here, okay, before this, let me do one thing. Array of, you remember tuple we discussed? I don't know how many you remember
Yes, Ravi.
tuples, right?
Combination of different data types.
Yes, this is my tuple. Record equal to this. This is my tuple. Actually, it's not tuple, it's array. Okay, tuple is different. It is array. Now, what I'm going to do here, val array of, I'm taking variables. First variable is name, second variable is age, third variable is salary. Here, equal to record. When I do this one, what will happen, name will get first element of the record, age, second argument will get second, third argument, you see here, name Vida, age 35, salary 1000.0 something. So it will get assigned like this. Whatever the values are there in every card, it will get assigned. So it means you are defining a variables. You are defining a variables here. These variables you are assigning a value. This value is not a single value; it's array of values. Okay, that's what happening here. You can take array. You can also take sequence. You can also take sequence. Oh, why sequence? Okay, since it is array. Okay, understand. This is array. Because of that, it is not taken. Okay, so if it is, yeah, since the first one is record is array, that's not, you are not able to assign array. So it should be a specific type. It should be specific type. That's the reason. You see a combination of different type. That's not, it's not able to fit it. Okay. So that is the reason array of elements I'm taking here. I'm passing the arguments. These arguments, whatever the elements are there in these arguments, and this is array, right? In the main method, you can see it is array. Since it is array, since it is array, see, here also sequence will work because you have to take the same type everything. So let me show you that also. You may get a doubt. It's array of string. In command line, everything will consider the string only. In command line, everything will consider the string only. So record. Is incompatible with the pattern type. It's a sequence only, right? String type, any type. Required string found any. Age string, name string, salary string. I check this one. Something is missing, but array it's working, right? So should work with the string. Sequence also. I don't know why it's missing. I'll check that. So you have array. Okay, you have array of arguments you are assigning. That's what this here it is doing. Okay, set of arguments you are assigning to set of variables. Once this variable is done, this is specific to this project. Okay, some helpers dot initialize. So he's putting this executor query and configuration to separate initialization. Okay, then he need to connect to the Impala for that Impala configuration. So it's, no, it will not be always the same. It will not be always same as our what I can say. All the projects it will not be like it won't be the same. Okay, it can be different. But what we have to actually look at from here. This is a Spark context. This is our Spark session, and here we are creating a Spark streaming context. Spark streaming context. So normally, what we will do, we will create our Spark session, and also we will create a Spark streaming context. Streaming context. It is not normal simple context. It is streaming context. We actually read the data. So streaming context. The context come and your batch interval. Batch interval is something. Batch interval is something. So I told you the micro batches, right? Micro batches. So how much time I need to create one batch? How much time I need to create one batch? 10 seconds, 30 seconds, or 40 seconds, or 60 seconds. That batch. In 60 seconds, whatever the messages I get, I'll create one batch. In 60 seconds, whatever the data I'll get, I'll create it as one batch. That's a interval. Okay. Once that is done, I don't know what is this remember. I'll see. I'll look into this. What is a remember? Next, he's creating his SSL and other stuff. And you look at here, you know, right? Topics we can send as a list. We can send as a list of topics. It can be one topic. It can be multiple topics. From that, he's creating one list. Look at the common parameters: your Bootstrap server, secure protocol, SASL Kerberos, security, offset. We discussed this one: auto offset reset latest. I told you latest, earliest. There are different things. You can specify the specific offset. So this is the latest. Every time you now reset, it will be taking the latest. Key deserialization, value deserialization, group ID. Enable auto commit. By default is false. Why? We are committing manually. These are all Kafka parameters. Whatever we have discussed so far last few days, the same only. We are creating our parameters. Is this clear, ma? So far? If you find any difficulty understanding anyone, not only Prapunna, anyone, if you find any difficulty, please let me know. I'll recap or I'll just repeat. Is this clear? I don't see any responses. Okay. I'm assuming that you guys understand. This is simple your parameters. You have not yet connected to Kafka. It's a simple parameters. Then, and we have taken this SSL value, right? We're checking here. So we're creating our trusted key location is this. Our trusted password location is this. Okay. Once you Kafka parameters are ready, Kafka parameters means your SSLs and your common parameters. This both. So once the Kafka parameters are ready, okay, we are trying to connect to Kafka. So we have to connect to Kafka. Before connecting the Kafka, there is one more thing we need to do. What is that? Offset management. What is offset management? I need to collect my offsets. I need to get my offsets. Yesterday, till what message has been processed. Today, what are the messages I'm going to process? That information I required, right? that information we will get from the offsets. So these are all very simple. These are all the project specific. He has a splitting method because he is getting the single line. The whole record is getting as a single line. That a single line he is splitting. So he split it with a comma. After comma, splitting with a comma, the zeroth position he say date. First position he say entity name, family name. So like that, he is splitting it. Nothing else. He's just splitting it here. Okay, and these are all date format he's taking. What are the date format he's going to use in his application? So these are the date format. Now, these are all struct type to create our data frame. These are all is project specific from here. So it's up to you. If you get the similar kind of requirement, we'll do similar kind of requirement. Will if it's not, we will not. Okay, next. This is offset schema, offset topic name, current offset. So what we do here, we try to get offsets. Look at here, select partition name, partition number, topic, and current offset from the offset table. From the offset table. Here, the offsets we are maintaining in a Hive table. Offsets we are maintaining in a Hive table. So your offsets can maintain your RDBMS table, your HBase table, or your Hive table. So we are getting the offsets. DF means data frame of offsets. So once we get the offsets, so we are creating those offsets as a map. Your topic partition. Actually, I didn't explain this part as part of the KAFKA to explain here in the streaming. We can connect to the topic and specific partition. Here, I have a consumer. What these consumers will be doing, they'll be connecting to the topic randomly some partitions. Correct? It is connecting to random to the partitions. But I want to specify which topic, which partition it has to connect. This is what that topic partition, your uh, first partition, your offset. Partition 1, offset. Partition 2, offset. Partition 3, offset. Like that, you can actually connect topic wise. Whichever the topic you want to connect, you can connect to the topic wise. Topic wise, partition wise. Topic wise, partition wise, you can connect. This is what uh, we are actually doing it. Specific partition we are connecting. Specific partition we are connecting. So the specific partition, how you are connecting, you are actually specifying which partition you have to connect. Which partition you have to connect. Okay. So once you connect to the topics, this is the most important part. Kafka utils dot. See, if you have offsets, offset length greater than 0 means you have offsets. If you have offsets, Kafka utils dot create direct stream. Create direct stream. I told there are two type of streamings. There are two type of streamings. One is receiver based, one is direct. Receiver based and direct. So receiver based, what we do, we will connect to, we will write our own receiver, and the receiver will read the data from the specific topic. But here there is a problem in the receiver based. There is a problem. There is a data loss. There is a possibility for the data loss because let me show you that. Receiver based source. get to that. It is not a straightforward. This is custom receiver. So I have bookmarked it, but I don't know where it is. Spark with the Kafka integration. Guide. Okay, let me directly search it. There are two approaches. This is the document I was looking for. Look at here. One approach is receiver-based approach. Other one is direct approach. Okay. Here we will not be having any receivers. We will directly connect to Kafka. We will directly read it. So if you read this one, what it is clearly saying, uh, this approach uses to receive a receiver data. So there will be a receiver to receive the data. The receiver is implemented using Kafka high-level API, consumer API. As with all receivers, the data received from Kafka through receiver is stored in Kafka executors. Sorry, Spark executors. It's stored in Spark executors, and then the job will be launched by Spark streaming process. So first, what it does, it receives the data. The data will be there in your executors, your Spark executors. However, under default configuration, this approach can lose the data under failure. To ensure zero data loss, you have to additionally enable write ahead a log. This write ahead a log is nothing but your checkpointing. We'll talk about that. Okay. This synchronously saves all the received Kafka data into write ahead a log if you have that in a HDFS, so that all the data can be recovered on failure. Okay. In this streaming programming guide, we have mentioned here what it is. So what it is happening in the receiver based approach, it will have a receiver application. That receiver application receives the data. That received data will be saved into Spark executors, then it will launch. In case of in case of any failure happen, there is a possibility of the data loss. That is the reason we'll not go with receiver based. Okay, so how the receiver based approach we will create? Very simple. Look at here. Kafka, it will create stream. Kafka, it will create stream. Your streaming context, your zookeeper quorum, your group ID, your topic, and that information. Okay, it means you're directly connecting to your Kafka. Then it will start read the messages. Okay, once you start read the messages, you will get on the Spark streaming application will be processed. But when it comes to the direct approach, this is a newer receiver-less direct approach has been introduced in Spark 1.3. It is not an older one, it's already there. I mean, it's something new, it's already there in the 1.3 itself. To ensure strong end-to-end guarantee, instead of using receivers to receive a data, this approach periodically query Kafka of the latest offset in each topic and partition, and accordingly defines the new offset ranges to process each batch. When the job to the process the data or launched, Kafka Simple Consumer API is used to read and define the range of offsets from the Kafka. Note, that is a feature of the introduced in Spark 1.3 for the Scala Spark API. This is talked about what is all explained. Here, there is no reading the data, storing it and all. So direct. Read the data, process it, and whatever the offsets you have processed, commit those offsets. That how it will be read the data and process. Okay, so here to connect direct approach, what we are doing, same, we will be using the same package itself, I mean same dependency itself, but here the method will change. Kafka it is dot create a direct stream. The previous one is a create stream. Kafka it is dot create stream. It is create direct stream. Okay, create direct stream, and will pass a key value deserialize, key deserialize and other stuff. Your Spark streaming context and your Kafka parameters and your set of which topic you want to consume, you will consume. Okay, then look at here. Whatever the this offset range we already did, no? This offset range we already taken. Let me show you that offset range. This offset we already fetched, right? We already get the offsets. The offsets you have created as a map, topic wise, partition wise. I meant to say, partition wise you have created. Okay, you are using your create direct stream method. You are using create direct stream method. You're passing Spark streaming context, and you're passing your offsets, you're passing your parameter, Kafka parameter, and you're passing your you're sending you're sending it as a list and a Kafka parameter, and your offsets range also you're sending. Your offsets range also sending. So with the help of this information, it will connect to the Kafka. It will create a direct stream. We'll call it as a direct stream, discrete stream, D stream, discretized stream. It will create a D stream. Once you create a D stream, look at here, guys. Once you create a D stream, we will apply for each RDD. Why I'll apply for each RDD here? Because your D stream object is, let's go now to the actual API. Once you connect to your Kafka, once you start reading the data, you will get the D stream. D stream is nothing but discrete stream. Discretized stream we'll call. Discretized stream. Like how you have a data frame, how you have RDD. Similarly, there is something called D stream. Similarly, there is something called D stream. D stream is also collection of RDDs. Nothing different or nothing new. So also look at here. Discretized stream or a D stream is a basic abstraction provided by the Spark streaming. It is represent a continuous stream of data. Normally, RDD data frame is nothing but collection of data. Here also continuous stream of data. Either the input data stream received from one source or processed data stream generated by transforming into a stream. Internally, a D stream is represent a continuous series of RDDs, which sparks abstraction of immutable distributed data set. Whatever the data you're reading again from the Kafka is not, it's also reading it as a RDDs. It means you will be having a set of RDDs. You will be having collection of RDDs or continuous collection of RDDs, series of RDDs. When you have multiple RDDs, you need to extract RDD by RDD. No, you have to extract RDD by RDD. How will you extract RDD by RDD? With the help of for each RDD. With the help of for each RDD. You are reading for each with the help of the for each RDD. You are reading RDD. It means you are reading first RDD, second RDD, third RDD, and so on. There's a loop. So for each RDD is nothing but loop. You're actually doing that. After doing that, what you're doing, once you got your RDD, from that RDD you're extracting the offsets and offset buffer and the other stuff, and I mean which partition it has been read, and we can see that one. No? Yesterday in the consuming also we have seen, no, which partition, which topic, which offset we have extracted those fields, right? So the similarly we are extracting here. After that, this is what actually we need to look into. I got the RDD. This is my RDD. I'm applying the transformations, map transformation, and I'm taking the data. Splitter. The splitter is nothing but here you see the method, no? Earlier, this is a splitter method. Why I'm doing the splitting? Actually, I want to create a data frame, nothing else. It is coming as a RDD. It is coming as a collection of data with a comma separated. I want to split it. So I'm splitting it. Once I split it, I'm creating a rows. Once I create a rows, I can easily create a data frame. I'm splitting it, creating as a row, row RDD. Once you get the row RDD, you know, right, how to create your data frame. This we have discussed. An example I can show you here. That application is not there here. So we already did it. We have rows of RDD. Look at here. This is sequence of rows. Once you have a sequence of rows, once you create a row RDD, it is not a string, it is a row. Row is a class name, right? Once you have a row RDDs with the help of the Spark streaming, create data frame, with the help of the create data frame. Your row RDD, your schema, your row RDD, your schema. Okay, here also same. Your row RDD, your schema. Schema is defined here. First column is date, second column is entity name, third column is entity family, name, result, value, date. These are the different columns. So here the schema is created. Once the schema is created, once the schema is ready, once your row RDD is ready, you are getting data frame. You're getting data frame. So then once you get the data frame and data frame operations, so I'm not going to get into those stuff. This is their business logic. It can vary business to business or project to project. Once the data frame is ready, you'll just go ahead and do all your transformations on it, data frame transformations. Once your data frame transformations and your process is done, if you look at here, so he did he took the distinct values and he filtered and all stuff he is done, and he's actually writing into table. Uh, get here partition union is did. After that, he did the coalesce of write mode. Look at here. This is a data frame. He's writing into append mode, partition by this column into in the Parquet format on this location. In this location, after writing it, uh, actually he's writing into Hive location. Okay, he's writing into Hive location specified partition. After writing in it, so we have to alter table, table name, partition. This is the partition key. This is the partition value, and set location. Locations are setting and running the client. I mean, running the query. Nothing else. So here loaded the data into Hive location and updated the partition. Okay. So once that process is done, so again partitions offsets also has to write, right? Offsets also need to write. Data process is completed. Offset needs to be committed, no? That's what here offset is committed. Offsets also taken, writing into Parquet format in the specified offset table and executed. Okay. So this is how the data process happens in the Spark streaming. And actually Spark streaming will be started and it will be terminated, await termination. It will be done. So this is how the Spark streaming application. This is just a sample to get you the familiarity. So tomorrow what I will do, I'll explain you what is this document completely, what is a dstream, what is the Spark streaming application, how it will read, how we will connect, what are the integrations. The Spark streaming is the Spark can connect to different, not only Kafka, it can connect to Kafka, Flow, or a directory. We'll see one directory example. Reading the data from the directory, Kinesis, Twitter, any of the streaming applications. Your Spark streaming can connect. It can read the data from them. It can write into any of the sources. It can be HDFS, it can be Hive, it can be HBase, it can be Cassandra, it can be RDBMS, it can be anywhere it can write. Okay, we'll see in detail about it. So while reading the data, we need to remember one thing. While reading the data, it reads as a batches. Look at here. Internally, it works as flows. Spark streaming receives live input data stream and divides data into batches, which are processed by Spark engine, generate a final stream results as in the batch. Okay, try to remember. It is a near real time. It's a batch process. Batch process. 1 second, yes. So we'll discuss in detail about these things, how data will be read and how the micro batches will be converted, how these micro batches will be processed. We will see those things. So what are the operations can performed on the D streams? What are the operations we can perform on the D streams? We can see those things also. Map, flat map, filter, repartition union, all these things can be performed on it. They're all direct. We already see in the core Spark core. there is specific window operations. These are all window operations. We'll call window operations. So those also we'll see. Count by window, reduce by window, key window. So there are window operations. So we'll also discuss about them in the coming classes. Okay. So that's it for now. So let's connect in the next session. We'll
Ravi, I
discuss
have
it.
a question, Ravi.
Please go ahead, ma.
For every Spark streaming data, first we need to split the data, then convert the data into data frame, then create a RDD. From there, we need to process the data, right?
Yes, we really no need to split in the sense you're talking about RDD split or data micro batches split.
Data, micro batches split.
No, that will be done. Micro batches split done by your Spark. You really no need to do that. You
Okay,
just need
because
you
here
just
we split the data row wise, right? By separated by comma and everything.
yeah that see once this is so again I'm repeating from here. Once you create a D string, this is your D string. Okay, it the
Oh,
D string the D stream is nothing but what? Collection of RDDs. That's what I have explained. That D stream is
yes,
nothing but a series of RDD. Each RDD contains some data. Each
yes.
RDD contains some data. Let's say I have 100 records are there. Each record will be comma separated in his input. In his input.
Not from
Okay.
here, Ravi. Before that, first we'll get the streaming data, right?
This is here only we're getting the streaming data and we're applying the for each RDD and we are taking the RDD. We're applying the for each RDD and we're taking the RDD. This RDD he is splitting here. See, he's converting his RDD. He's converting, he's applying, he want to get the row by row. He want to get the row by row. So once he get the row by row, he's taking splitter. This is what you're talking.
No.
This is just a
Before
method,
this.
ma. This is
Okay.
just a method. This is just a
Here,
method.
here. Okay.
This is method. This is just a method. This method is getting called from here.
Okay.
He's calling that method from here.
Okay. Splitter. Okay.
This this he's not doing the data splitting here. It is a method. Whatever you pass to this method, it will get split like this.
So whatever the message means data he's getting, so he did like this, like converted into different columns.
Yes, because in his environment, he is getting the data in the form of text.
Okay, okay.
I think I
Got it.
do have a small sample data here. Let me see. I think I have sample data. No, I haven't. So he is getting the data text comma separated one. That is the reason he is splitting it. It's not really required to split. You can he can convert as a sequence and he can convert 2DF function he can apply, but he don't want to do that because he don't want to miss any of the column. So
Okay.
what he did, that's the reason he whatever the message I read as a RDD, this is RDD, right? So look at here, row is what he's taking the row and the first one he's defining a key and value. This is what we
Okay.
get the data from RDD. Once he
Yes,
get
yes.
the row, then he's splitting. He's splitting. The splitter splits the data, nothing else. It don't do anything else. It just split the data. Then splitted data he's converting as a row of what I can say row method. So
Okay.
ultimately
Now I got
he's
it.
doing like this now. Ultimately he's doing like this. At the
Okay,
end,
okay.
after applying his map method, he will get one row like this. Say he will get this part. First column, second
Okay.
column, third column in a row, in one row. This is another row. Like that, he will get a collection of rows. Once he get the collection of rows, what he will do? RDD. He will create RDD. He will
Okay.
create
I
RDD.
got it.
One RDD is ready. Schema also ready. Schema already there now. I have shown you.
Yes, yes.
Schema also ready. First column, second column, third column. So RDD ready. Schema ready. So very simple. Create data
Applying
frame.
the transformations. Okay.
No, no. Create data frame. Then pass your RDD and schema. You'll get the data frame. Create data
Okay.
frame function. With the help of the create data frame function, RDD, you'll get the data frame. Okay.
Okay. Yeah.
Once you get the data frame, you know what are the transformation you need to apply based on your business.
Yes, yes.
Okay. Yeah, we'll see in detail from next session. Okay. So,
Okay, Ravi. Thank you.
okay. So that's it for now. So I'm closing the. Whoever joined for the next session for Scala, please stay back. I will connect in a minute.